Good morning, students. I am Dr. VIJAY BHANDARI, Associate Professor in CSE Departments. So now we are going to perform experiment number 6. The name of the experiment is implementation of support vector regression using Python. Okay, so before this, going to implement this regression using Python, we must understand about what is support vector regression. So I will tell you about support vector regressions. So now first I will tell you the support vector machines is a popularly and widely used for classifications problems in machine learning. Support vector regressions uses the same principle as support vector machine, but for regression problems, let's spend a few minutes understanding the idea behind support vector regressions. The problem of regression is to find a function that approximates mapping from an input domain to real numbers on the basis of a training sample. So let's now dive deep and understand how support vector regressor works actually. Now we focus on our objective. When we are moving on with SVR, means support vector regression, is to basically consider the points that are within the decisions boundary line. Our best fit line is the hyperplane that has a maximum number of points. We will understand the use of support vector regression with the help of data sets. Okay, so now we are implementing here our support vector regression. So now we are going to perform on a Sublime text editor. Okay, so this is a light process editors, and what we see here, first importing the libraries. Okay, so first we import numpy as an np and import mat.lib.pyplot as a plt, and then import pandas as pd. So in the first cell, we are importing necessary libraries as like pandas to give structure to our data, numpy to perform mathematical and the other relevant operations, and mat.lib to create charts. Now, second cell shows about the importing the data sets. Now we uploading the data sets from the VIJAY machine learning websites. You can download the data set very easily, and data sets is equal to pd.read. So here pd we are using this to giving the structure of our data or reading the files. Okay, so now we calculate the index value is mentioned here. As we already know, index in Python starts from 0. That's why height column is depicted by the index value 1. So now I am splitting the data sets into the training sets and test data. Okay, so this you can see here, splitting the data set into the training sets and test sets. Now we move next cell. We are taking in classes, importing the standard scalar class from the sklearn pre-processing. Now we creating our objects as c_s and as c_y. Okay, this is the method standard scalar, and we are fitting and transforming the values using this and x and y. Now fitting SVR to the data sets. Now we creating our class SVR. This importing from sklearn.svm. So this is the SVR is a support vector regression class. Okay, so now we are creating our own objects regressor, and the kernel will be RBF. Here we are using kernel RBF. Okay, so regressor dot fit x comma y, and this method is applying on the data and predicting a new results in the next cell. Now why we are predicting and using the y underscore prediction function is equal to regressor dot predict. It will, this functions will shows here to predict the regressor and how many data points, how the data points are set into a straight line, and now visualizing the SBR results. Finally, we got the results and using PLT dot scatter, and now we can plot the graphs, plot the charts, and the line is giving a red color. Okay, and PLT dot plot x regressor dot predict color is equal to blue. This means regressor dot predict. We are doing this predictions using regressor dot predict function. Now it will shows the by the blue color. Okay, then we are renaming our plots truth or bluff. This is the x-axis and y-axis on salary. Now PLT dot show, it will show our graphs. Now we are moving into an next cell, visualizing the SBR results for higher resolutions and smoother curves. So these steps are creating higher resolution and smoother curve. Okay, so now we can run this code and get the results. Now we can see here, this is the result of our program, truth or bluff. So this is the x level and this is the y-axis. So x-axis is the position level 2, 4, 6, 8 to 10, and this is the salary source on an y-axis. So this is the line which is a predictable line, and this is the actual data sets. So there is less accurate, but this shows our regression lines. So hope you understand. Okay, so if any doubt, so you can ask me. Okay, so that's it for the day. Thank you.